We're detecting over 100 zero-day software supply chain attacks every single week right now. And the vast majority of those do not get CVE numbers issued. They do not get reported. We report them to the package registry so we can attempt to get them taken down. We treat them as, like we want to get we want to protect the community and get that code taken down if we can. But we often find that these registries, they're run by volunteers and they're not very responsive sometimes. Sometimes they are, sometimes they aren't. It's very inconsistent. And so, if you look at our threat feed right now, you'll find, I can pull it up right now. You'll find packages published an hour ago that are malicious, that we've identified, again, within a couple seconds of it being published, that they're malicious. But they're still live on the package registry. And sometimes they stay live for weeks. And we want to be able to protect people even though that code hasn't been taken down yet.
Assemble the council.
Today, our special guest is Feross Aboukhadijeh. Feross is founder and CEO of Socket. Socket is a developer-first security platform that stops vulnerable and malicious open-source dependencies from infiltrating your software supply chain. The bold print on the Socket website says, "Secure your dependencies. Ship with confidence." That's just the beginning of this story. We will be talking entrepreneurial spirit today. We will be talking founder mode. We will be talking open source security. Feross, welcome to the Cybersecurity Council. Please say hello to our audience.
Hey, everybody. How's it going? Thanks for having me here. I really appreciate it.
I'm very glad to have you here, Feross. And full disclosure, you are a sponsor of our upcoming event. In just a few days, we're having our first annual conference at the Q2 Stadium here in Austin, Texas. You will be there with us physically and in spirit. So we will be hearing a lot more about open source security in the next few days. And I thank you for being a sponsor. I would like to go back in time and fully introduce you to our audience. I've had the privilege of interviewing some big names here in security lately on this very podcast, and I was a little bit shaken when I realized I was going to be able to get to interview you as well. Your record speaks volumes. So I'm going to take a moment and do a crash course through some of the things that you've done in your career. So please indulge me. Let this happen. Listeners, brace yourself. Number one, Feross went entrepreneur early. A side project he started in high school called Study Notes offers study tools and college prep to high school students. I believe it's reaching over 800,000 students per month at this point. 2, Feross is a Stanford graduate. He has both a bachelor's and a master's in computer science. Stanford is known for excellence, research, innovation, and that's going to be a theme across what we're discussing today. 3, Feross has been a teacher, visiting lecturer, instructor at Stanford, computer science section leader. Call that right out. 4, and this is where the story of Feross starts to go into light speed. You build and sell a company to Yahoo in 2013. It's a next generation CDN. I don't even know what to say. It was so fast and so sharply done. And I've got some questions. 5, you begin deep diving into open source. And I mean deep. You're working with WebTorrent as an open source developer. You're working with MIDI, and that's a music production protocol. You're helping Brave Software implement and integrate WebTorrent. You start working on standard JavaScript. So you're not even doing the basic things. You're like, let me hack away at the language itself. 6, you return to Stanford. You're doing more visiting lectures. 7, and this is more light speed. You're working with Andreessen Horowitz. So you're an investor, you're a venture capitalist, you're talking to people in the business, in the know, you're helping companies happen. And here we are at number 8. You are a founder and CEO of Socket, developer-first security platform. I have to take a deep breath. That's a little bit of a crash course. You're a person that matters. You've done the technology things that matter. You have my attention. Now, Feross, I've just oversimplified your career. I don't want to do any disservice to you. So, what needs to be immediately corrected or expanded so our listeners can understand who you are? And again, thank you for being here.
Yeah, thank you for that intro. I didn't expect you to go all the way back to my high school projects, um, I think you did a great job covering the different projects I've worked on. If I had to say what the theme is of the kinds of projects that I like to do and the kinds of companies I like to start, it always has to do with doing something that surprises and delights people. And I used to do a lot of hackathons in college, and one of the things you learn from competing in hackathons is that you have to think about what the demo is going to look like. What is the experience of the person who's watching what you're building, and what are they going to feel when you demo it? And you can build toward that. And the best trick, the best thing to do is to surprise people with what computers can do. Because as computer scientists, as programmers, we have the power to build. I mean, we can build things in our mind, right? We can build machines and abstractions out of thin air, out of code, and it's so there's this. You're basically a magician, frankly, if you're a programmer, So there's so much we can do, and there's so much stuff we can build, and so everything from WebTorrent to the first company, Pure CDN, to even Socket now. I think a lot of people thought that it couldn't be done. The space we're in, software composition analysis, hasn't really evolved in 20 years. People thought there's no way to stop this type of an attack, that the kind of software supply chain attacks that we stop. And so even with the current company, that's kind of been the theme, is just surprising people with what you can show them is possible.
I thank you for that, and I'm pleased that that is embedded in the ethos of Socket. Please start right there. Define Socket for us. Take us through what that security platform is all about.
Yeah, for sure. So I spent a lot of time writing open source software throughout the last decade. One of the things I love open source, right? There was a time back when people were debating whether or not open source software or proprietary software was going to win. And we're way past that now. And it's unequivocal that open source has won. But unfortunately, security has been a bit of an afterthought. So the big change that I've seen happen over the last decade is that we've gone from using a small amount of open source to a large amount, but also the way that those projects are constructed has changed. So it used to be that you could name on one hand or two hands the number of open source dependencies that you were using to build your application. There were these large dependencies, things like jQuery, WordPress, Apache web server, PHP. You could name these dependencies, and they were usually foundations or large organizations and many, many hundreds of folks working on each of these projects. And what I witnessed in the JavaScript community, which is where I spent most of my time in open source, is that we shifted to a model where you have, instead of hundreds of people working on one project, you have one maintainer working on hundreds of projects. You have these almost super maintainers, is what you could call them. And in this model, you have oftentimes a lot of trust placed in a single individual maintainer, and you have a lot smaller packages and therefore a lot more packages. So today it's not uncommon to find applications using hundreds of dependencies every time they bring in a single dependency because of transitive dependencies, meaning you think you're installing one package, you're actually bringing in hundreds of packages. And so when you build that up over time throughout an application, you end up with tens of thousands of dependencies. And we have some customers that are like 50,000 dependencies in their organization. So in each of those has a person behind it, or a small number of people behind it who you have to trust, and you basically have direct access to your application, right? I mean, whatever code they publish is going to run in your application. And that's fine. Most of the time that works, but we've seen a lot of attacks happening in the last 5 years, software supply chain attacks where that trust gets violated, gets taken advantage of in some way. And so that's why we started Socket. Basically, I saw too many of these attacks happening. I felt like there's a thing we can do to solve this. And it's hard. And there's a reason why people haven't tried this before. But if we solve it, it's a really big problem that we're solving. We're helping people to trust the foundation upon which they're building their whole business, their whole product, their whole application. And that's the thing, is most applications have tons of open source code. Like they're built on, 95% of the lines of code in the application come from open source, not from the code that the developers wrote. And so when you have this model where, you're depending on this mountain of open source code, software security isn't just about the code that you write. It's about every piece of code that you depend on.
Okay, Feross, I would like to meet you halfway on this. I come to this battleground having helped set up a couple of open source software management programs at some of my former employers. So I would have been like the lead security engineer. Here's how we're going to do it. And we would identify and address license risk. We would identify and address the vulnerabilities and the transients and other parts of open source libraries. But in a lot of ways, that is both unsophisticated and it's totally limited to governance choices. I know Socket is smarter than that. So take me to the ways that you're doing things that would cast a shadow on some of my former efforts.
Yeah, no, but let me just start by saying you shouldn't feel bad about your former efforts, because this is very hard. And until Socket came out and, had a product that you could go and use, this was a very hard problem to solve. I talked to a lot of CISOs who told me before we started the company, they told me that, yes, this is one of the top 3 things that keeps them up at night. They're worried about all this code that their developers are just constantly pulling in. No developer actually reviews the code contained in the dependencies. And like I said, these can number in the tens of thousands for complex applications. But what were they to do? No CISO, no security practitioner wants to be the wet blanket that tells the developers that they can't do something, that they can't ship features that slows down the developer velocity. It's just, you don't want to do that. I worked at a company, I worked at Yahoo back in like 2013.
2010.
I think it was 2013. Was it 2010? They actually did have a open source czar who approved every single open source dependency across the entire organization. Actually, it might have just been the node dependencies, but in any case, they tried to have like a gatekeeper who would approve these things. And so you had to go argue with one guy in the company in order to bring in new code.
There's always a guy.
There's always a guy, but it didn't scale, right? And so I've worked anywhere else or really seen anywhere else where that's the process. Usually the process is developers can bring in whatever they want. If they want to ship a feature, they do some Google searches, they read some Stack Overflow answers, they learn, oh, there's a library that does this, there's a library that does that. Maybe they even use ChatGPT today and it suggests some libraries for them, and then they just blindly pull it in because it solved the problem. Maybe if they do some investigation, they go and look at the number of GitHub stars or something like that, and they say, oh, it seems popular. But they're not looking at the code. And even if they did go in to look at the code, they're not looking at every update to the code. They're not looking, when a new version comes out, people aren't assessing whether the new version is safe to bring into the organization. And often that's the way that a software supply chain attack can happen, is that you pull in a new update that was published by somebody different. A different maintainer took over, an attacker got access to the maintainer's machine and was able to put out a bad package. Or in some cases, the maintainer themselves decides to go rogue and even sabotage their own package. We've seen a surprising amount of that around different political protests in the last 4 to 5 years. There was a big one where around the Ukraine-Russia war, where somebody put code into their package that would wipe your hard drive if your IP address was Russian. So it would just go iterate through your one file at a time on the whole system and replace the contents of the file with a flower emoji. So it was like, it's kind of funny, but it's also not, because nobody wants that type of a booby trap inside their application, even if it doesn't trigger for you. It's like, it really affects the trust in open source for that kind of thing to be going on. And So you asked the question. I should actually answer your question, which was how do we do it better than what most folks are doing with just traditional vulnerability scanning or traditional SCA tools. And to answer that, what it comes down to is we're doing a much deeper scan of the package. We're opening up every package and doing what we call deep package inspection of open source dependencies. So we're scanning for indicators of malicious activity, such as backdoors, obfuscated code, typo squats, the use of risky APIs. And then we're doing that in real time. So whenever a package is published to any open source registry, whether it's NPM, PyPy, RubyGems, Maven, whatever ecosystem you're getting your packages from, we know whenever a new package is published within a couple seconds, we pull down the package, we open it up, we go through every file in an automated fashion, and we look for any capabilities that stand out, like, hey, is this package accessing the network? Is it reading your environment variables where your API keys and your tokens live? Is it reading files or writing files to the file system? Is it have obfuscated code? Is it evaluating strings and at runtime? Is it automatically running code at installation? Is the name of the package similar to the name of a more popular package, which would indicate this might be a typo squat attack where they're hoping that you install the wrong package when you run your install command, and the list goes on. We have actually about 70 different things we look for today. And so that allows us to identify when a package has become bad or if a package is bad at the earliest possible moment, basically seconds or even in some cases, a couple minutes after the package is published, which is just very, very different than how most software composition analysis tools work, where they're really just looking at detecting vulnerabilities by referencing these kind of stale databases of vulnerabilities, which is just frankly too slow and too reactive to actually catch a supply chain attack, because you're relying on, again, this database that isn't updated very frequently, that has a listing of all vulns in it, which is just, by the way, the other big problem is that database, that CVE database that everybody uses, it's by the way, it's, in case you don't know, it's from the federal government. There's a thing called the National Vulnerability Database that they all pull the vulns from. And that thing, first of all, having a lot of problems right now. It's not getting updated very frequently. They have a huge backlog. They're now contracting with third parties to try to get through the backlog. And it's not in a good shape. But on top of that, they don't even track when packages are malicious or when they've had backdoors added. Those packages they're not valid. You can't get a CVE number for those. So there's no one tracking this today. So even if those are identified and we report them and we get them taken down from NPM or GitHub or wherever they're hosted, they refuse to issue a CVE number, which means there's no reporting mechanism for you to find out in your organization if you've installed one of those packages. You might be using one today. You might even have replicated into your internal mirror, your package mirror, your Artifactory or whatever you're using, and you might still be hosting it for your developers to install, even though it's been removed from the public registries. And so it's just, there's all these problems with the way that it works today. So we're trying to fix all that. We're trying to be the kind of solution to all the problems with open source trust.
You're bringing a lot of enthusiasm to this discussion, my friend, and I very much appreciate it. I'd like to check my understanding. Instead of a trusted repository, you're not hosting a trusted repository, you're checking the health of things in the wild. Is that right?
That's right. And then we provide that information right at the critical moment where the developer is bringing it in. So whether it's their IDE, whether it's in the pull request that they're sending to GitHub or GitLab or whatever they use, if at that moment they're bringing in that bad dependency, we're going to tell them, hey, that's not something you want to use. But we also, obviously, you might already have existing dependencies in your organization that you want to know about as well. So we also can obviously provide that visibility. But I just think it's really important to emphasize the best time to catch these things is before they've even been brought into the application, because unlike a vulnerability where you have some time to fix a vulnerability before you're attacked. I mean, often there's some critical ones, but in general, vulnerabilities, I like to think of it as it's like leaving your window unlocked. Someone might try to get through the window at some point, but probably if you left your window unlocked for a couple weeks, you'd probably be fine, right? Whereas a malicious dependency, it's someone is breaking through your window and your door and getting into your home. It's a very different type of an attack. So you don't want to wait around until the developer's already brought the dependency into your app, and then you're doing a scan after the fact because it's too late. You've already run the malicious code. So you really want to get ahead of it and be as early as possible in the developer workflow. Is that making sense?
It is making sense. Is Socket getting queued from security checkpoints in the pipeline? Is it happening at the developer IDE level? Where is this taking place?
Yeah, so most folks just put us into GitHub. We have a GitHub Marketplace app that you can just install, and then we sit right in the pull request workflow. So as the developer sends that pull request in, we're going to be one of those checks that runs along with their tests and their other CI/CD scripts that run. But you're right that we want to be in as many places as possible, and so we do have an IDE plugin. We do have the one I'm most proud of, actually, that I think is the most interesting and most unique that we offer, is we actually have a Chrome extension and also Firefox and Microsoft Edge, etc., that you can install or you can roll out to all your developers across your organization, which is, by the way, very easy to do through Google Workspace. If you have a Google Workspace, you can just say, roll out this extension to everybody in certain groups. And so we've had many customers do this for all their developers. And what the web extension does is anywhere they go on the web where they're browsing and they're reading a tutorial about how to implement something, or they're reading a Stack Overflow answer or a blog post, or even using ChatGPT or these other AI tools to generate code, whenever a reference exists on the web page to a package, to a third-party package or a dependency, the web extension will underline it in red, like a spell check, to tell the developer when there's a severe risk in the package. So if ChatGPT recommends some dependency that's been abandoned 5 years ago because it's trained on really old blog posts, technically it solves the problem, but it's a really bad dependency that nobody should be using anymore because it's not maintained, it's abandoned, and it's old. Socket will, right there in line in the answer, will add a little red underline and say, don't install this because it's malicious, or don't install this because it's abandoned, don't install this because XYZ, whatever it is that the problem is with the dependency. So that's literally as early as you get. I mean, this is at the point where the developer hasn't even written any code yet. They're just considering what dependency they could use to make their problem easier. They haven't even wasted any time building a feature on top of a bad dependency that they're going to have to get told later that they can't use, right? So it's so efficient because they don't waste any time. It doesn't slow them down. It gives them that info before they've even made the decision to use it. And really, I like to call it a speed bump or a nudge, because that doesn't really stop them from using it. If they can always install it. In the case of a web extension, we can't prevent them from installing it, but we can at least nudge them and say, hey, it's a really bad idea to do this, and give them that information that they're not getting right now, because they're not, like we said, they're not opening up the dependency and looking at the code to see what it's doing and looking at the risks. They're not doing that kind of an analysis. So we can just give them that insight without them having to do any work, put it right in front of them.
That type of flexibility has got to be very powerful for the developers themselves. It's got to make DevOps happy because they don't have to retreat from deployments that they're trying to make. And they don't have to, do any rework. I'd like to go back to a couple of things you said earlier. You were talking about the CVE backlog. Does that imply that you live in a world of interim CVEs where you, Socket, are like, this is a problem. I know I can't report it. It's just going to go into the backlog, but I need to make sure that organization X is aware of this vulnerability. Are you so advanced you're operating in some kind of interim world? You're solving some problems for some folks in this gray area?
Yeah, I mean, that's absolutely right. We're detecting over 100 zero-day software supply chain attacks every single week right now. And the vast majority of those do not get CVE numbers issued. They do not get reported. We report them to the package registry so we can attempt to get them taken down. We treat them as, we want to get we want to protect the community and get that code taken down if we can. But we often find that these registries, they're run by volunteers and they're not very responsive. Sometimes they are, sometimes they aren't. It's very inconsistent. And so, if you look at our threat feed right now, you'll find I can pull it up right now. You'll find packages published an hour ago that are malicious that we've identified, again, within a couple seconds of it being published, that they're malicious, but they're still live on the package registry, and sometimes they stay live for weeks. And we want to be able to protect people even though that code hasn't been taken down yet. So it's very important. If you want to stop a zero-day attack, you have to be able to catch it and to maintain that database separately from the very slow-moving national vulnerability database.
Everything you're saying works for me. I'd like to ask you to inhabit a solution architect frame of mind. A startup, a small and medium business approaches Socket. They want your solution. How do they integrate? What are the timelines? What tools? What questions do you ask? When do you say use the web extension? When do you say use the checkpoints? What's kind of on your mind as a solution architect trying to help a new client?
Yeah, the easiest way to get started with Socket is to use our source control integration, like our GitHub app, because it's in the GitHub marketplace. It's literally a 2-click install. It's the easiest security tool that anyone's ever used. Everybody tells us this. Our customers always tell us this. And the best part too is we don't access any source code. We don't need really any proprietary data to do what we do. We just look at the list of dependencies that are in use by looking at the manifest files. The package JSON, the requirements.txt, this type of data. But we're not touching PII or any kind of proprietary source code. We don't run at runtime, so there's no need to install an agent, which can be risky and cause stability issues in some cases. We don't require the developers or the security folks to go project by repo by repo and add additional steps to run in the test suite or in the CI suite. It's done with one click. You just boom, you're on every repository in the GitHub organization. So it's really fast, literally 2 clicks. Once you've done that, you've gotten a few things out of the box. One, you have now visibility over every single dependency that's used in your organization. So you get a full list. If you ever need to produce an SBOM or someone asks you, hey, if your board member or your CISO comes to you and says, hey, we need to know, are we using Log4j? Which repositories are using Log4j? We can tell you because we know every package that's in use across the whole organization and where it's being brought in. But then on top of that, we can also track the changes over time. So every time a developer makes a commit, that's a checkpoint for us. We know, okay, the dependencies have changed now. And same thing with pull requests. When a developer is proposing changes in a pull request, we know, okay, this dependency was present in this pull request. And that's very helpful. If it's there, you know that it probably ran on the developer's machine. So if it turns out there's something malicious that was used in a pull request, the developer probably installed it. And that's probably something you're going to want to look into to see if their machine is safe. So we basically have full visibility on where dependencies are being used in the whole organization. And then you also get a view into what the risks are of those dependencies. So anything you would want to know, right? If you want to know, tell me all my dependencies that have vulnerabilities, that's obviously table stakes. We obviously do that, but you can also get a listing of, any dependency that is unmaintained. A lot of folks like knowing what dependencies you're using that are abandoned so they can start to work through that tech debt. Even engineering teams like that. You might want to know what dependencies you're using that have recently had a new maintainer join the project, because that creates risk. You might want to know every dependency that contains obfuscated code, because that's really weird, and you probably shouldn't have anything using obfuscated code. That's a huge red flag. If something's doing that, you want to look into it. We've had companies where they've had 3-4 findings like that, and they've looked into it and said, okay, this is really weird. And in some cases, it was code that the maintainer wanted to hide from people, and that was hidden in the package. In other cases, we identify packages that have very low download counts and seem very unpopular. And when the company looks into it, they learn that one of their developers forked a popular package to fix a bug or something like that, but they are now hosting it in their own personal namespace. And now if they leave the company, if they're a former employee, they're no longer at the company, they now have a route into the supply chain of the company, even though they're long gone from the company. And that's we've identified many instances of that where it might have been innocent, but still that's something you want to clean up. You don't want to be depending on former employees' GitHub projects, especially if they didn't leave the company on good terms. So there's all these kinds of stuff we can give you in terms of visibility, not to mention the most obvious one, which is stopping, detecting malware. Hopefully you have no malware, no malicious packages in your dependencies right out of the gate. But if you did, we would find that as well. So that's all the visibility stuff. And then finally, the last piece is you also get out of the box developer interventions and developer education and this whole developer facing part of the product where as the developer goes about their business, opening up pull requests, they're going to be given feedback right in line in GitHub, educating them about threats, blocking them when you want to block them from proceeding if it's something is really bad. And developers love it, really. Like one of the few tools I would say that like you can have confidence that if you put this in front of developers, they're going to find it useful because Socket is already like, first of all, our whole team is open source maintainers. So we know how to build stuff that developers like to use. De facto, I mean, I have code that gets 1 billion downloads a month. I know how to make, stuff that developers like to use. But also, a lot of security tools are bought by executives, and then so they're designed to sound good to an executive, but when you actually go to use it, it's horrible. It in the best case, it sits on a shelf and it doesn't really help anybody. It just becomes shelfware, and in the worst case, it gets deployed and then it like slows the developer down. It prevents them from getting their job done, and they hate it, right? And they rebel against the whole program, and the security team loses a lot of trust and credibility in the organization. So Socket is not like that. It's designed right out of the gate to be useful to developers. It doesn't block out of the box, so safe to roll us out. And as you build confidence in the tool, you can turn on certain things and make them blocking, like malware, like significant critical threats and stuff like that. You can make that stuff blocking in a really progressive way. It's really, really nice and low risk.
You've outlined a very comprehensive piece of software here. This sounds like a full suite. I'm certainly interested just myself. Can you disclose any success stories? Have you had some significant influences out there in the market and you're like, yep, this is the way to do it?
Well, I just mentioned some customers that have given us permission to share their case studies. We're used at a lot of the largest and most well-recognized AI companies, including Anthropic, and some other ones as well that I can't mention. But we're also used at the largest SSO provider, and we're used at Figma. And we're used at platform, like kind of cloud providers like Vercel. We're used at a lot of Web3 customers. So MetaMask, all the wallets like Phantom Wallet, Rainbow Wallet, Alchemy, because the crypto people actually really understand supply chain security and risk. If they have a supply chain compromise, then it's game over when those keys are stolen because those funds are irrecoverable. So we've actually had a lot of success in that space. And then we're also in regulated and kind of finance as well. So we have one of the big 4 US banks using us, one of the largest telecoms. And then a lot of compliance tools as well. Drata, Vanta, these companies folks might be familiar with, are using us as their SCA solution. So just like a large swath of users. We usually either come in as the replacement for SCA. So if you have an SCA provider that isn't really doing a great job for you, or you recognize it has these gaps around detecting malicious packages and being really proactive about it and educating developers and preventing that stuff from getting in the first place, and you want to upgrade to something that's modern, because a lot of these, by the way, a lot of these SCA things, like I mentioned, they haven't really changed their approach in 20 years. It's the same stuff. It's just reselling this public data. Honestly, it honestly should be free, in my opinion. And these tools should be, because it's such a commodity. Like there's like 100 vendors that it's all the same thing. It's all just a CVE scanning solution. It's not interesting. It should be a commodity, honestly. So we do that stuff, but then we do all the other stuff, all the fancy new stuff around, detecting these sophisticated threats and these other sources of risk, the the tech debt and your dependency tree and all that stuff. So if you want to replace what you're using, it's a very easy migration. We switch a lot of people over from tools like Sneak, for example, and stuff like that. But then we also have people using us as an add-on. If they're happy with their SCA solution and they just want to get a gap, they want to close the gap around malicious dependencies, then they can just bring us in as that like extra layer. So we've had some people, their board told them, you need to have some solution for software supply chain attacks because they got freaked out by the XC attack earlier in the year, or they had a close call with a malicious dependency, or they maybe installed one of those things and they got compromised, and they want to close that gap. Then we can do that for them, and you don't have to rip out the whole SCA solution that you're already using. So those are the two most common ways. And then we also sometimes have companies come to us and say, look, we've already built our own really sophisticated kind of scanning solution, and we just want to pull your threat data in as basically a threat feed, a data feed that they can pull in and just have all of our insights along with the CVEs that they're already using. And so then in those cases, we actually have a threat feed offering where they can just purchase the data feed and they don't need the rest of the platform. So those are the main ways people are deploying Socket.
Tell me about the Socket team today. How are you outfitted? What kind of roles do you have? You've mentioned that you are a bunch of open source enthusiasts, and I'm going to use the word nerds, which is absolutely delightful. But just tell me about your team.
Yeah. We started the company back in 2020. We still are a very efficient team. Shout out if anyone's looking for a job or hiring. We're looking for a ton of different roles right now. Engineering, product design, security, sales, post-sales, technical account management, all that stuff. We just raised a Series B round of funding recently, $40 million. That's going to set us up for a great future of just being able to invest more in product and growing the team. So
my grandpa advice is don't spend it all in one place.
No, that's the thing, is that's what so many companies do, and it's such a red flag. If you're looking for a company that's going to stick around, you don't want to go with one of these companies that's just spending money like drunken sailors, because especially in the current environment that we're in, it's not easy to raise funding, especially Series Bs. I just saw some data from Carta, which is, tracks a lot of people's cap tables and knows all about funding rounds, and they shared that the number of companies that are able to raise a Series B round after within 2 years of raising the last round has just gone off a cliff. It used to be something like 20% range, and now it's like down to like under 10%. In the case of Socket, we raised we raised our Series B less than 18 months after the A, which is something that only 4% of companies in their data set, were able to do. So it's a good group to be in, raise funding in the way we've been able to do, especially from such great investors. Like we have Andreessen Horowitz, Elad Gil, just amazing folks involved, and a lot of folks in the security world too, that I really respect. People like Zane Lackey, the founder of one of the founders of Signal Sciences, and Andrew Peterson and the rest of the SigSci team, and then folks like Haroon Mir from Thinkst, folks like Ryan Noon from Material Security, the Okta founders. I think all the Okta founders invested in Socket. So there's a lot of good folks that we're able to bring in. But back to your point, like it's so important to be efficient in the current market, and to really just have a high hiring bar for who you want to work with, who you want to bring in as a colleague. And that's because A players hire A players, but B players hire C players, right? And so it's just really downhill really fast if you try to grow super fast. And it's just really, it can be really painful for everybody involved if you overhire and you have to correct for that, or worse, if you don't correct for that and you end up with just running out of money and the whole company having to shut down. So yeah, I would just say that's one of the things I'm most proud of is we've accomplished so much with actually being very, very lean. And this funding is going to be used very strategically to just go faster on a roadmap, just deliver some stuff a little bit sooner than we would otherwise to our customers. And we're getting a lot of like great feedback from people, and it's all stuff that we want to do. And so we're just going to use it to go a little bit faster. And also, go to market is really important, like hiring the sales team that's going to go and get this product out and put it in everyone's hands. That's really important. So
Feross Aboukhadijeh, you are fast, you are nimble. I am enjoying talking to you because you are coming with the insights one after another. I absolutely predict you're headed towards some domination here. You're going to use your Series B funding correctly. I absolutely know it. I'm a believer. I want to see you succeed. If there's anything that the Cybersecurity Council can ever do to continue to help Socket, we're here for you. I'm looking forward to seeing you later this week. Feross, thank you for coming to the Cybersecurity Council today.
Thanks for having me at the Cybersecurity Council. I'm excited to sponsor the upcoming event, and then also hopefully in the future. I really like what you guys are doing, and it's not often that you can find folks that are actually practitioners all meeting and just having educational events, and also just a chill place to hang out that isn't just a massive sales pitch. And so yeah, excited that we're sponsoring the happy hour, and hoping to chat with a lot of folks there and have a good time.
Thank you for seeing the truth of it, my friend.
Yeah, thanks for having me, Scott. I really appreciate the time and the opportunity.
Assemble the council.